In this video, we're going to look at how to verify trigonometric identities. So let's look at an example. And here we have the sine squared of theta plus the cosine squared of theta all over the cosine squared of theta secant squared of theta equals 1. And we want to verify this. Okay, now there is a couple of rules about this, and one of the big rules is that you have to pick one side. And it doesn't matter which side you pick, you have to pick one side and you've got to make it look like the other side. So we could either start with this left side and work our way down to make it look like 1, or we could start with 1 and work our way down and make it so it looks like this. Now in general, it's better to choose the side that's more complicated, because it's easier to take something that's complicated and make it look like something simpler than taking something that's simpler and making it look more complicated. I mean, think about this. You'd have to start off with the number 1 and somehow get to this part of the identity. All right. After that, there is no hard and fast rule about how to verify a trigonometric identity. You just kind of look at it and think, what do I need to do in order to make this look like this? Now, we've already talked about some strategies in previous videos, and one strategy is to look at this idea that, well, I have these trig functions that are squared. Maybe I could take advantage of a Pythagorean identity. And in this case, we can. We have the fact that the sine squared of theta plus the cosine squared of theta equals 1. So we could actually substitute in 1 for this. So we already have 1 over the cosine squared of theta times the secant squared of theta. So that was a pretty basic substitution in there. Then we have to look at this one here, and they are squared, so maybe we're thinking of using a Pythagorean identity. But another technique we've talked about is turning everything into terms of sine and cosine. So we know that secant is 1 over cosine, so we would have 1 over the cosine squared of theta times 1 over cosine squared of theta. Okay, cosine squared times 1 over cosine squared becomes 1. So we would have 1 over 1 equals 1, and finally 1 equals 1. And we verified this identity. So, all right, let's try another example. Let's say we want to verify the identity. And let's say we have 1 over 1 minus the cosine of beta plus 1 over 1 plus the cosine of beta equals 2 cosecant squared of beta. Okay, so we have another example of we pick one side, and we got to make one side look like the other. And so it looks like in this case, this is the more complicated side, or this is the side we're going to choose. Another thing that I didn't talk about up here, just to verify, is you can't add or subtract to both sides. So it's like we can't take this and bring it over here. When you work on one side, you're only allowed to work on that side, and there's nothing else you can do over here. So just be careful of that. All right, I think in this case what we're going to do is let's go ahead and combine fractions. Now, in order to combine fractions, we do have to have a common denominator. And it looks like that common denominator is 1 minus cosine times 1 plus cosine. So we're going to have 1 plus the cosine of beta all over 1 minus cosine of beta times 1 plus the cosine of beta. And then we're going to have 1 minus the cosine of beta all over 1 minus the cosine of beta times 1 plus the cosine of beta. Okay. Now that we have a common denominator, we can combine them. So we get 1 plus the cosine of beta plus 1 minus the cosine of beta all over 1 minus the cosine of beta times 1 plus the cosine of beta. Okay, so looking at this, it looks like, well, these cosines cancel out, and 1 plus 1 is 2, so we get that, 2. And why don't we go ahead and multiply these together? So we get, let's see, 1 plus cosine of beta minus cosine of beta minus cosine squared of beta. These cosines cancel out, so we get 2 over 1 minus the cosine squared of beta equals 2 cosecant squared of beta. So it looks like we're getting pretty close. Now we got it, but we still need cosecant over here. So we got to think, what else could we do with this? Well, again, when you have a trig function squared, one thing that pops into our brain is a Pythagorean identity. And so we know that the sine squared of beta plus the cosine squared of beta equals 1. So the cosine squared of beta equals 1 minus the sine squared of beta. So let's go ahead and substitute that in. So we're going to have 2 over 1 minus the quantity of 1 minus the sine squared of beta. I'm kind of running out of room here, but I think I'll be able to make it. So then when we distribute the negative, we get 2 over 1 minus 1 plus the sine squared of beta equals 2 cosecant squared of beta. These ones cancel out, and I'm just going to go over here. These ones cancel out, and we end up with, right here, 2 over the sine squared of beta equals 2 cosecant squared of beta. Actually, that's not enough. I'm getting another sheet of paper here, just a small one. So to rewrite that again, it's going to be 2 over the sine squared of beta equals 2 cosecant squared of beta. Go ahead and scratch that out. And then we know that sine squared of beta is 1 over, so we could separate this to be 2 times 1 over the sine squared of beta. Is that equal to cosecant squared of beta? And 1 over sine is 2, cosecant squared of beta equals 2 cosecant squared of beta. And that's because 1 over sine is cosecant.